Okay guys, let's talk about electronics. Electronics is network of components that allow electricity to pass through them in order to carry out a particular purpose. Now, that network of components is network of basic components. We have resistor, we have capacitor, we have what again? We have inductor, we have what? We have transistor, we have diode, and the rest. So this is the network, something like this network. This is just a simple network. Now, this network, we have an inlet where electron goes in from, and an outlet where electron leaves. So an electron flows in from this direction and leaves this whole network through this point. So if you are to connect this network to a battery cell, to a battery or power source, this is where you will use to connect it from. This is the point, which is called terminal. This is called terminal, and this is the second terminal. Now we have two terminals. We have the negative terminal, we have the what? Positive terminal. So current goes in to a circuit or network. Network is also called circuit, or circuit is called network. In electronics we call it circuit, so we don't really call it network, call it circuit. So the current goes in through this negative terminal and leaves the circuit through the positive terminal. Now if you are to connect your battery, this is our battery, this is our battery with the negative and positive. So this will be the negative and positive terminal. So you are going to connect this to your negative, and this one you are going to connect where? To your positive. With that, you have made what they call closed circuit. There is a closed circuit between this battery and the circuit. Now you might ask, why is current flowing from negative to positive? I know in school we are taught that current flows from the positive terminal to negative, but that is called conventional current flow. But the actual current flow is from the negative to the positive. This is your battery. The negative is always ready to give out electron, while the positive is always ready to receive electrons. So that's how it works. Current flows from the negative of a battery back to the positive of the battery. You can see that there is a continuous line of flow can pass through this place, get to here, or it can pass through here, but it will always find its way back to the battery. Let's imagine something happens to this line here and it cuts. There becomes a bridge or an opening. An opening happens here. There will no more be current flow. Current will no more flow from the battery through the circuit and back to the battery. That's when we'll have a fault called open circuit. This is an open circuit. When there is an open circuit, no current will flow at all. When there's open circuit in any part of this diagram, if there's an open circuit any place, there's an opening any place along this circuit, whether it happened here, whether it happened here, or it happened here, or it happened at this point, any point at all, there's an opening, there won't be current flow again, and your electronic will stop working. Now there's another kind of fault that happens too. The fault is called short circuit. Short circuit can happen at any place too, but it always happens between two opposite connections. Let's assume something like a conductor falls in between this place. There will not be a direct link from this point to this point. That's what we call a short circuit. A direct link that doesn't pass through any component. Mind you, short circuit can happen any place. Short circuit can happen between this point and this point, thereby bypassing this component here. Let's assume a short circuit happens between this point and this point. Is going to look like this. So current that is coming in, that is supposed to flow through this component to this one, will no more pass through this component again. See how it will flow. It will flow from this place to pass through this short circuit, and it will go direct to this place. So if this component is meant to have a function, if it's meant to have a function here, and you have bypassed it through this short circuit, the whole system will malfunction. Let's assume this one reduces current that comes to this place. Now a short circuit have happened and this current will no more be reduced. That means large current is going to flow to this particular circuit, and what will happen? This one will burn out. You get? So this is the simple things that causes issue in electronics. The first one I said is open circuit, and the second one is what? Short circuit. Short circuit. But if everything is fine, the whole connection is good as it's supposed to be, and there is continuous electron flow, that's when you have what is called closed circuit. At this point, everything is fine. Everything is fine. Now take note, I'm not using a physical image to demonstrate. I'm using drawing. Now there are two types of drawing which you can use to represent electronics. One, we have schematic diagram. Two, second one is component diagram. Now I want to show you these components. These are electronic components. This is a relay. All right, this is a capacitor. This is a diode. This is a resistor. These two are resistors, diodes, and this is an LED. This is a preset, also known as variable resistor. Now this is a capacitor. This is a capacitor. Now, okay, this one also is a transistor. So if I'm to represent this diagram, these components in book, I can either choose to draw it like as this LED is. You can see how the LED is. So I can choose to draw it this way. You can see it looks exactly like what I'm holding in my hand. All right, it looks exactly like it. Or this other one, this is a diode. Now I can choose to draw this diode like this. Take note of the white marking here. Then I'll draw the leg and the leg. You can see it's just looking like what I'm holding, but there's another kind of way I can draw this. Now it will look a bit confusing. This LED, if I'm to draw it, okay, let me explain this. This particular type of drawing is called component diagram. So because it's looking like the real diagram, that's why it's called component diagram. But this other one, now this is looking very much different from what I'm holding. It's looking very much different. And this other one too, this is an LED, and this is a simple diode. This is a diode. This type of diagram is called schematic. And electronics are best drawn in a professional way. They are drawn using schematic diagram. You hardly use a component diagram, because this component diagram takes a lot of space. It's when you are making a description that you may use that component diagram, but when you are doing a design, when you are designing a circuit that is meant to be interpreted, you are going to make use of schematic diagram. Now those schematic diagram, each component has its own schematic diagram. This is a resistor, right? Now the component diagram for resistor is this. Some people make use of this. That's a resistor. In some books or in some electronics, depending on the country, you have this, while some other people make use of this. These two are resistors. They are called resistors. Now when you have to draw this particular one, that is variable resistor, see what you do. Because it has, you can see that this variable resistor has 3 legs, right? 3 terminals. Now this is a resistor, right? with 2 terminals. You will now have another terminal that goes in. This is the variable resistor. Okay, same applies to this one. You have making it a variable resistor. Now this is a relay. A relay comprised of both inductor and what switch. And you know we have our normally open switch. This is simply how our switch is. It is normally close to this point and this point. This is the common, right? This is normally closed, this is normally open. Now this is a transistor. Okay, I've not drawn the relay. There's an inductor inside of a relay. So this is how an inductor looks like. This is how an inductor looks like. You should have your connecting terminals. Okay, a transistor is a transistor. A transistor has 3 terminals: base. This is a transistor. It has terminal base, terminal emitter, and terminal collector. Now there are 2 types of transistors. We have this particular type is called NPN. Okay, now we have another type. The same collector, their terminals are the same: collector, emitter, base. So this particular one is called what? PNP. So that's how it is. Which other components? Okay, this particular one, this one here, a capacitor. Now this capacitor, this is how to draw a capacitor. That is simply how to draw a capacitor. Some people will go ahead to add positive, while some people will make it look like this. They are all capacitor. Now this battery will draw like this. Can represent this battery this way. This is a single cell. Okay, this is a single cell with our positive and negative. This is a single cell. You know, multiple cells form battery. So we have our positive, negative, we have another so this is our battery. This is how we draw battery. So this is just the basis. For those of you who don't know what to mean by schematic and component diagram, this is schematic, this is the component diagram. It looks like the actual diagram, and this is schematic diagram.